So nice of you to come on this early Sunday morning to hear something about Crinit, an embedded security-aware init system. But first of all, a little obligatory who's who slide. Andreas Zerster, that would be me. I'm a systems engineer at Emlix GmbH, which is, as the name kind of implies, an embedded Linux company who does board support package, kernel development, product maintenance, open source component qualification. Basically, if you have something related to Linux and embedded systems, good chance that Emlix can do something there. And also now, an init system. And we did that in cooperation with our customer Electrobit Automotive GmbH, which is specializing in automotive embedded systems like ECUs, driver assistance, infotainment, and generally smart stuff in cars. Right, so with that out of the way, first a little recap. Don't know if that's necessary, but what again is an init system? Most of you will have seen a screen like this, like once or twice in your life. Depends on the uptime of your system, I guess. This would be systemd doing its thing, starting your processes, your services for your system. Usually, or the kernel, when it's done and doesn't know what else to do, it starts an init process as the first process in the system, and then the init process is responsible to start everything else. Could be servers, services, SSH, whatever, until the system is ready and to react to your commands or react to the outside environment. And now, question, okay, why do we need another one? We have seen there's systemd already, there's SystemV-init. What else is needed there? Little disclaimer, some people may have strong opinions about init systems in general and their philosophical implications. I'm not one of them. Basically, both systemd and SystemV-init, which are the usual ones used, are great at what they do, usually on desktop systems. But we had some special requirements there, so little motivation. We wanted something specially developed for embedded targets with a small and testable code base, simple usage, and simple configurations. And of course, so we used BusyBox-init, because that checks all that boxes, but no, not really, because also we wanted parallel execution. Basically, this System5 derived inits and BusyBox-init kind of work sequentially. Usually, you have scripts that tell it what to do and when, but not too much parallelism. Systemd does that, but systemd kind of it's a huge thing with not that simple a code base. And also we wanted to get by without shell scripts, so System5-init throws out there. And then we needed configuration signatures. Basically, we wanted to give a way to authenticate your configuration of your system. And also, like systemd has a runtime configuration interface. Most of you will have used systemctl in your lives, probably a couple of times to, I don't know, start a HTTP server or something like that. We needed that too, and for example, BusyBox-init doesn't really have that. Then also, we wanted the possibility to integrate with another software of ours, that's ELOS, Event Logging and Service Daemon, which is able to gather events from all around the system, from maybe sensor data, system internal, external stuff, and then relay that to clients. And as you've maybe seen, I'm even wearing the shirt. And of course, it would make sense to have an init system there which can register there, take these events and react to them, and also tell ELOS, hey, maybe I just started a task, maybe a task is ready, maybe a task is done. And yeah, to the current status. What we have is right now, and what's going to be open source in just a few days, likely, maybe weeks, is that we have task configurations which can have dependencies with each other. So you can think of it like a task configuration that says, oh, I need another task to be started before me, or a system feature that needs to be present. And in your mind, this might look a bit like a tree, but also with cross dependencies, so a directed graph. Independent branches and parts of this graph would be run in parallel. So basically, if you have two independent parts of this graph, then you don't really know or care which one of those will be done first. And also, we have a control API, a library that you can link against, and tell Crinit to maybe start another task, stop one, or modify an existing one, or just to query if maybe, I don't know, SSH is already running or something. Then we have I/O redirection, basically everything you can do with piping in a shell, you can also do inside a task file that has something to do with that we wanted to not have shell scripts in it. And then you can set the environment, same way you would in a shell. And also we have include files, so you can have a bit of a system structure where you prepare already some settings, and then you can include other files and basically have preset settings for some vendor configuration files. I'll show you that. And yeah, two things which are marked almost because they are in very current development, work in progress. I guess they will be done slightly later than the open sourcing, so I kind of wanted to mark that so that when it's open source, you're not wondering why that isn't yet in there. Maybe it takes a week longer. That's the, as said, the task event reporting to ELOS and dependencies on them, and also the signature checking. And this is what I talked about. This is what an exemplary hypothetical task daemon could look like. Basically, you give the task a name, and basically most important thing is to tell it what to start. This would be some daemon, could be Apache maybe. Then this task has dependencies. Here, for example, this daemon would like to have a temp dir present, would have to like to have network present, and some other setup task file to be run before. In the other way around, this task file would provide some daemon and syslog, because maybe it's a syslog daemon. And that can tell other task files that they can depend on that one. Basically, that way you can have an independence in such things like another task may want to have syslog, but it doesn't care with which specific application that's realized. Otherwise, yeah, pretty standard init settings like respawn. Actually, I think that should be yes here because it's a daemon, but you know that from other init systems, it means if the task stops for some reason that it gets restarted. We can set if it needs to, if it should retry this forever or maybe stop after 3 failed attempts or something like that. And then we set the task environment. Basically, it does the same thing as exports in Bash. Here we have a variable name, variable setting, and also it supports setting it to another variable in the same syntax as shell. Also, you can have in the global config file environment settings that you can reference from here. IO redirection, probably almost self-explanatory. Standard out, standard error, and you can put that into a file, for example, log file, and could also be a pipe, a named pipe to send it to another task, and you can then redirect, for example, standard error to standard out as well to have both in the log file. Now, to get a bit technical, this is basically a representation of what happens when Crinit resolves dependencies. We can think of this as Crinit's internal state. Basically, up there you see an arbitrary number of tasks. That's state 1. These are tasks that Crinit has loaded from config files but not yet started. These have dependencies, abstract A, B, and C. We are at a university after all. And at some point now, B happens. B. What Crinit then does is it registers this event and looks into all its tasks. It remembers, crosses out the dependency if it's there, and then if it detects, okay, there are tasks that have no dependencies anymore, then these get started simultaneously in separate handler threads and then run basically or get monitored independently from the rest of the init system, and then can generate their own events when they are done. Okay, the API, pretty standard. I also already talked about it, that you can connect to a C API and do all kinds of stuff with tasks. You can also change global settings, and we also have a kind of bare bones implementation of SD notify. That's a SystemD API where you can tell the init system, hey, I'm actually alive and have pit something something. That is used in case you have a daemon that forks itself to the background and which looks to the init system like, okay, this has terminated. And with that, you can tell Crinit, okay, no, actually, I'm not terminated. I am still there, so that Crinit can keep monitoring you. The technical implementation is just a library, also a Crinit CTL service application similar to systemctl that uses that library, and the library basically just abstracts a Unix socket communication to Crinit itself. And now for something with cryptography. If that's now the thing that one of the things that's almost implemented, if so configured through the kernel command line, which is a secure thing if you use secure boot, then Crinit will verify the configuration files you give it for global settings and also for these task files we've already seen. And it would expect every configuration to have its own signature file, which has an RSA PSS signature of the whole file in it. It's the reason we use that is because NIST and BSE recommended both. So yeah, that is considered secure. And the way the key is managed is that we have that we expect a public key in the system keyring, which also would be a trusted source in a secure boot setting if you either compile it into the kernel then, or if you have maybe a hardware security module with a driver that then pulls out the public key into the system keyring. Additional downstream public keys can then be in the rootfs if you have like from third-party vendors which would like to write Crinit files. Then you can sign their keys with the system root key and have that in the rootfs. And if any of the keys match with a config file, then it's trusted. Okay, and now to completely challenge Murphy's law. I will actually start Crinit in a QEMU virtual machine of a very bare bones ARM64 system, just to show it off a bit. Whew, a lot of text here. And you see I'm arriving at the console. What happened there, you see a lot of output up there. It's just Crinit reporting that it has started some task causing to some dependencies. We can better see that if we do a Crinit-ctl list. And then we see, okay, we have, there's something like early setup, which just, did some mounting of def tempfs and all that. We started also elosd I was talking about, and that, for example, is currently running. The Getty I'm using here is currently running. You can maybe have a look at the Getty config file because it's a simple one. Yeah, just the name, the command, a dependency on early setup because it's a bit hairy to start Getty before these mount things have been done. And respawn to yes, so because we want to not get locked out of the system if Getty crashes, which I can now maybe induce, just to challenge Murphy a little more, by telling Crinit to kill that task. No, not Crinit. God, Jesus Christ. That actually wouldn't have worked. Okay, and yeah, we're back at the long int shell because Crinit killed the Getty and then respawned it as configured. Right. Then maybe one little interesting thing in the elos config file. Yeah, we have an IO redirection here to, as I said, elos is a logging daemon. In at least part of it is logging, and then the question remains: where does the output from elos go when it's not already logging? The answer here is into a log file. To get a bit of output there, I'll also kill and respawn elosd a bit. Woo. Just do that a couple times and then check the log file. And there's Murphy's Law. Okay. That did work before. I'm not quite sure why it does not now. Let me get back to you on that later and keep on doing this thing. Okay, to show off the dependency resolution a bit, I have created a few fake tasks. That would be the well-known programs water, people, heating, and chlorine. The story here is that imagine we have a new indoor pool that's now empty. And in order to let people in there and let them have fun, we need chlorinated water, and preferably it should also be warm. So just a story to make this dependency stuff more interesting. I hope it works. So let's check those out. First thing you usually do is let water into the pool, and then, at least I'm actually not a pool technician, so I don't know how the chlorination works. But anyway, in my mind, you first decide, okay, now I want to fill the pool. And so I want to first let water inside, and then preferably automatically have the heating start and also the chlorination. That works here by this addctl enable tells Crinit that, okay, you can load this task, but wait for an interaction from the control interface to start it. It's basically blocked by that. And then we have also the chlorine, which doesn't make sense to put it in without the water, so it depends on the water. And also the heating, which also depends on water. So what should happen now, and I really hope it does, is that we let water into the pool, and then automatically it will be chlorinated and heated. This looks so good to me. As we can see, the water has been let into the pool, it has been chlorinated and heated. So now, next thing would be to actually let the people into the pool, but now the pool administration has decided they need something interesting for the first day, which would be water toys, like, I don't know, air mattresses, stuff like that. This was kind of an unplanned thing. So the task was not in the boot process, not in the directory Crinit scans for tasks. So we just imagine I just wrote a new one in just this directory that's toys Crinit. As you can see, it depends just on people being in there. Basically, once the people are in the pool, they get thrown at with toys. And in order for that to work, I have to tell Crinit that this task exists and that it should load it. That would be home root toys Crinit. Okay, let's check it. And as we can see, toys have also been loaded. People are still waiting. Let's try it. Let the people in the pool. People have entered the pool, and also toys have been thrown into the pool, and people are having fun. Okay, that was the very short actual practical demonstration of Crinit. So back to the presentation slides. And it remains to tell you about our wider plans. I already told you about what is currently in development. And these are our plans for Crinit in the longer term, with the exception of the open source release. That's actually happening in, as I said, a couple days, maybe weeks. You can have a look at github.com electrobit Crinit, which will be the place where it's going to be. Right now 404, but as I said. Then we are planning better SD notify support and integration. As I said, it was kind of a bare bones implementation, but we're aiming for as much systemd compatibility as we can there, because a lot of daemons have patches or implement support for that. And then we also want to have another security feature so that you can run tasks with reduced capabilities and basically jail them a bit explicitly, not full containerization, because you can use runc for that, for example. The idea is to be able in the task file to say, okay, this should be another user, this should have reduced capabilities, maybe throw it in a C group so it plays nice with resources. And yeah, seccomp is also an idea to, yeah, syscalls, what do you call it, when you forbid syscalls, yeah. And of course, always we'd like to have more tests in there, code optimization, ongoing thing after it's been open sourced. Yeah. Little summary. Crinit, it's a new embedded image system. It's small, fast, as you have seen, and multitasky. You can tell it to do stuff through a library. Will work great together with ELOS. Also, kind of future tense, can check if someone messed around with your config files. And as I said, multiple times, soon to be open source. And if you want to, you can come to our booth and see it running together with ELOS. And I'd like to close with a testimonial from one of my esteemed colleagues. Once it's open source, I think I'll try this out for my own projects. Maybe, hopefully, you might too. Thank you. And if, yeah, you can of course applaud if you want. If you now have questions or maybe want to share your opinions on init-systems, their philosophical implications or anything, now's the time. Please. MIT. To the S6.
Yes.
I don't believe I do. Okay.
Because each task is node process, so the init and supervising, it's divided in several processes, but it has no check of the signatures.
I guess it's always good to have a little competition. Yeah. You mean the I/O redirection? Right. I mean, you could do that basically on foot by having a network file system in some way. I don't know. You could log to an NFS share. You could log to whatever virtual file system is your preference. Also, it's kind of a thing that could be solved with the ELOS stuff, where you could redirect the output through a pipe to syslog, and then ELOS would catch it and would put it wherever it logs, which could also be remotely. Yeah? Oh, sorry. I should have repeated the questions. Okay, how do I rephrase that? The question was, in the, okay, sorry, can you?
Just how to integrate.
Right, network logging and I/O redirections. How would you do that? That was the answer just now. Yeah. Yeah. Oh yeah. Why wouldn't we use shell scripts? It's kind of a thing for some embedded systems to actually not have a shell at all. For one, keep the system small, and also it's the thought behind that is to reduce attack surface, basically. If you can't even log into a system, makes hacking harder. Okay. Anything more? I guess then, thank you all.